Today we're taking a look at our next calculus differentiation rule. Previously we talked about power rule and product rule. Today we're moving on to quotient rule, our division setup here. So how do we use quotient rule to find derivative? So anytime you say divided by, and actually not every time, but when you say divided by in a problem, when you're taking the derivative of, then you use the quotient rule. Now one note to make down here. This is only for rationals or fractions with variables in the denominator. Okay, and I'll show you an example of the opposite of that in a second. So the actual quotient rule is as follows. If we have something f of g, so something on top, something on bottom, and we're trying to take the derivative of it, here's the pattern for it. We take the derivative of the top, times it by the bottom, minus, take the top, times the derivative of the bottom, and then take the bottom and square it. All right, so go ahead and just make a note of that. So that's our quotient rule. Now, something we're going to talk about real quick is when it looks like quotient rule, but you're actually not going to use it. Do not use quotient rule for the following. If you have an equation on top and just a number on the bottom, so see how that's just a number, no variable, or if it's just a number on top and an equation on the bottom. So we need variables on top and bottom to actually use the quotient rule. So examples of these where we're not using the quotient rule would be something like, let's say they gave us x to the third over 5. Now it does look like a fraction, it does look like division, does look like quotient, but this is really, we can just rewrite this as 1/5 times x to the third, and really this is just power rule. Okay, it's not actually product, it's just power. We're going to multiply this times that and then take it down by 1. So it'll be 3/5 x to the second. That's the derivative of this. So not quotient rule that time. Okay. Same thing if we saw 1 over, well, let's put y first. 1 over x squared. It looks like division, but that top isn't a variable. Okay, that's just a number on top. This can really just be rewritten as x to the -2, and again, that's power rule. We multiply that down and then bring it down by 1, so it's y prime is -2 x to the -3, and we can clean that up some more to -2 on top and x to the positive third once you put it on the bottom of the fraction. Okay, so some of them look like quotient rules, but you only have to use it for certain cases. So let's see where those ones start. So for example, differentiate, find the derivative of the following. So y equals 3x over x squared plus 2x plus 1. Okay, this time it is a fraction. We have a variable on top, we have a variable on bottom. So I'm going to write down that power rule again, or sorry, not power rule, but the quotient rule. It's derivative of top times bottom minus top times derivative of bottom over bottom squared. Now, this thing on top is going to be f, this thing on bottom is going to be g, all right, f and g, so let's plug that in. So lots of plugging in, lots of figuring this out. So y prime is, let's go piece by piece. I need the derivative of the top. So derivative of the top would be 3 times the bottom, so just write what the bottom is, minus the top, 3x, times the derivative of the bottom. So let's see, move that down, that's 2x plus 2, and then the 1 disappears. All right, so if we want to label this again, this is derivative of f, this is g, this is just f, and this is derivative of g. And then on the bottom we want to take g and square it, so bottom squared. So x squared plus 2x plus 1, square the whole thing. All right. So the rest of this from here on out is just trying to simplify this down. So up here, let's multiply that 3 to all of these. So 3x squared plus 6x plus 3. Multiply this in minus 6x squared minus 6x. And then on the bottom, well, looks like we're just leaving that alone for now. You can square that. You'd have to write it twice. Remember that exponent 2 doesn't get applied to everything. That means write it twice. But it looks like we're just going to leave that alone for right now. You guys know how to do that. It's just not something we're going to work on right now. On top, we can combine like terms. A 3x squared minus a 6x squared gives me a negative 3x squared. Positive 6x and negative 6x cancel each other out. And then we're just left with plus 3. And on bottom, let's just go ahead and leave it like this. You know we have to square that, but for right now, that is our answer. We've taken the derivative. Okay, so let's see another one of those types. Polynomials on top and bottom. So let's take the derivative of y equals 2x to the 4th minus 4x cubed minus 2 over 4x squared minus 3. So this piece on top is f, this piece on bottom is g, and remember we want the rule to be f prime times g minus f times g prime over g squared. Alright, that's the rule we're using. So let's go ahead and do it. So y prime equals, going to need lots of room here, piece by piece. So let's do f prime first, so the derivative of f, so the derivative of the top. Boom, that gets multiplied. So 8x, this comes down by 1, cubed, minus, that multiplies, 12x squared, 2 disappears. Alright, that's my first piece, that's f. I need to multiply it to g, so 4x squared minus 3, and I'm going to need a lot more room, minus, let's do the other part now. Whoops. Alright, so we've done f prime, we've done g minus f, 2x to the 4th, minus 4x cubed, minus 2, group it. I need to make this fraction bar a lot longer. And I still need to multiply that to the derivative of g, so the derivative of the bottom is 8x, just 8x. Alright, on bottom, it's going to be g squared, so take g, square the whole thing. Alright, so we've got a lot of work to do on the top, and this looks like FOIL here. 8x cubed times 4x squared is a 32x to the 5th, minus 24x cubed minus 48x to the 4th, and plus 36x squared. Over here, I'm going to take this 8x and go all of these, but then we got to remember this negative sign here. So negative 16x to the 5th plus 32x to the 4th plus 16x. What a long, difficult problem. Not really difficult, just interesting. And looks like we can just leave the bottom alone for right now. Let's like terms anything on the top. So y prime equals, biggest exponent is 5, so 32x to the 5th minus 16x to the 5th gives me a 16x to the 5th. Next biggest one is 4, so negative 48, positive 32. That gives me a negative 16x to the 4th. Gone. This one's all by itself, so minus 24x cubed. Actually, everything else is by itself. 36x squared plus 16x. Gone. And we'll just leave the bottom alone for now. But we do know how to write that out twice and multiply it. Okay, so that there is the derivative of the original function. All right. Now I want to go ahead and take a look at a couple of trig ones, just because we like to throw those ones in as well. So for example, we want to find the derivative of secant x over tangent x. Now this is quotient rule because there's variable on top and bottom. Top is f, bottom is g. Remember the pattern is f prime times g minus f times g prime over g squared. So let's go ahead and do it. So y prime equals, I want the derivative of f, so the derivative of the top, and derivative of secant. If we look back at our original day, we did derivatives. The derivative of secant is secant x tangent x. All right, there's f, or sorry, the derivative of f. And then g is times tangent minus f is secant x. Multiply that by the derivative of g, so the derivative of tangent is going to be secant squared x. And on the bottom, tangent x, let's square the whole thing. And we can clean this up a little bit more. Y prime. On top, we got to multiply these together. So a tangent and a tangent makes two tangents, or tangent squared. So we have secant x tangent squared x, remember that's where you put the exponent 2, minus, I've got one secant and two secants, make three secants, so secant cubed x over tangent squared x. Alright, and that's the most we can do for this one. One more trig function, then we're good to go for today. Let's go ahead and take the derivative of y equals cosine x over x squared. So we've got a little bit of mix and match on this one. Again, top is f, bottom is g. So we're using our quotient rule over g squared. Okay. So y prime equals, take the derivative of the top, so cosine. Derivative of cosine is negative sine, and then multiply it to the bottom, which is x squared, minus the top, cosine x, times the derivative of the bottom, which would be 2x, and then on the bottom take g, but square the whole thing. So not too bad. So the derivative, we just go ahead and rearrange the terms. That's negative x squared sine x minus 2x cosine x over, this is x to the fourth. Alright. Now that is a good answer for now. There is a little bit of reducing that we could do. So like on top, I've got an x squared here and an x, so I can factor out an x. So I can factor out 1x, leaving me with negative x sine x minus 2 cosine x over x to the fourth. And the reason we did that is because now we can cancel out one of the x on top with one of the x's on bottom, so now it's x cubed. So really not too big a difference, but now we've got a little bit simplified answer. So negative x sine x minus 2 cosine x over x cubed.